I have a Q&A here open, so you can just drop me a question anytime. I'll try to answer all of them. And since there are no questions yet, I will start working here. So good evening or good morning or good day to everyone. Thank you for joining. Thanks, Jimmy and Voxel 51 for organizing this thing. I think it's really cool for machine learning scientists and everybody working in this field to be gathering here together and just sharing ideas, working on open source stuff, and yeah, just spreading knowledge, because that's basically how this whole field of computer vision and machine learning kind of got to existence, by using the open source things. So I'm really happy that we're continuing the development and sharing knowledge here. All right, so the subject here today for me is food waste classification using AI, and I'll talk about the FiftyOne tool that Jimmy Dow mentioned a bit, and how we are utilizing it quite a lot here at Kitro for a lot of different things, but mainly for just enabling food waste classification and making our models work even better than they are. All right, so first I'll start with the structure of this talk. I won't bore you much. I'll do a short personal biography just so you know who's talking. And then I'll talk about Kitro. Kitro is the company I'm working with now. And this whole thing is about Kitro, the whole talk. I'll talk about what we do. And what we do is we're trying to solve the world food waste problem. I'll tell you how we do that, who are our customers, what is our product, and what are our further developments in this field. And later, I'll talk about something that's maybe more interesting to all of us, is how we're working, what is our machine learning pipeline, what is food classification, how we pick up classes in this field, in these data sets, and I'll share a bit about how we're utilizing FiftyOne here at Kitro. All right, so short first about me. I'm Luka. I'm born and raised here in Zagreb in Croatia, in Europe. I finished the mathematics high school, and then I've moved on to finishing the electronics engineering master's degree. But during the master's degree, I was fiddling with electronics, but also fiddling a lot with computer vision. And during that time, I am young, but this field is actually even younger. And neural networks and strong GPUs were not really widely accessible. So most of the image processing was done with the traditional methods. I've done a lot of things with the histogram before it, and gradients and stuff like that. But then I enrolled in a computer vision PhD, where I did a lot of machine learning and deep learning. I published quite some number of journal and conference papers, got some citations, also got the outstanding award for the outstanding PhD in my faculty. And the things that I was working with were mostly ultrasound image analysis. And just one thing that you need to know about this field is whether it's medical ultrasound, whether it's non-destructive testing, whatever it is, you really don't have that much data to work with. And a lot of the data is just clean data. You don't have a lot of positive examples of some flaws or of some malign tumors or whatever. So I was working with GANs, with a lot of generative models, diffusion models, to trying to kind of enlarge the data sets that we had. And I also work with a lot of object detection and self-supervised learning, trying to utilize all of the images and samples that don't have any anomalies on it. Yeah, so I was working 4 years as a young researcher here at Faculty of Electronics Engineering and Computing in Zagreb. And then I briefly, for a year, worked at this one Croatian robotics company. I was working as an AI research project lead, and we were developing robots, and I was actually developing computer vision solutions and signal processing for autonomous robots that were just going to the nuclear power plants and to some pipelines. And even I worked on a lunar exploration mission for the European Space Agency, stuff like that. That all sounds interesting, but then I got an offer, a really good offer, for this amazing startup called Kitro. That is the main topic here, and here I'm head of machine learning from last year, and yeah, I'll tell you about it. It's really it's really an amazing company, and what we are doing here is really cool. So, anyways, about Kitro, enough for me. The goal of Kitro is simplifying food waste management. It was founded in 2017 by these two entrepreneurs, Anastasia and Naomi, and they were working in the hospitality industry. They were working in the hotels or something like that, and they couldn't wrap their head around the amount of food that was getting wasted in these hotels, in these luxury hotels, in the restaurants, on the events. It was just a huge waste of resources that nobody seemed to care about. And that's why they had an idea. They had an idea how to solve this problem using machine learning and AI. And right now we are a strong-standing company with around 20-ish employees, and we have a lot of different departments. And but the most important, maybe to you and for this talk now, is the electronics and software and the ML department, which I'm the head of. So, okay, what is Kitro? Why food waste? What's going on here? Our vision in Kitro is to bring back the value of resources. So yeah, so they are appreciated and they're not wasted. The problem with food waste is it's hard to measure. It's a thing that people just do and they don't think about it. But it's really money and CO2 emissions and a lot of resources, water consumption that we're just throwing away. I mean, we wouldn't be throwing money in the bin and just burning it. So why are we doing that with the food? Well, the problem is that usually it's hard. People don't know how much they waste. How can they reduce their waste with the food? And that's what we're trying to solve here with artificial intelligence. So right now there are millions of tons of edible food that are wasted every day. It's a huge problem, and 2/3 of the food that is being wasted is edible, and it could have been avoided, which is really dramatic. But we don't have the exact data on how much food is being wasted. A lot of this food waste comes from production, from events, from hotels, from restaurants, basically from the hospitality industry. But they don't know how to measure it. They don't know what to do with it. But what if the idea is, what if we can measure food waste? What if we can reduce it? But how can we do that? And here I present you the Kitro's main product is the Kitro Tear. It's a scale which you can see, on which you can put a lot of different size of buckets. It's really sturdy. You can jump on it, you can throw it, you can do whatever, and it won't break. It has a scale on the bottom, and it has this huge neck which can extend. And on the top is a camera and a processing unit, and yeah, and this thing can every time somebody throws something in the bin, it takes a picture automatically and does the analysis of the food waste. It can also connect to the internet, and this is really convenient and this is what distinguishes us from the competition, because it's really just a simple solution for every kitchen, for every, I don't know, restaurant, wherever you want to place it, you can put it somewhere and it will work. You don't have to do almost any setup. You just throw the food in the bin like you used to. But then comes the fun part. Our pipeline goes like this. So we have the scale called a Kitro Tear, and at some point somebody throws something in the bin. We call it a trash event, and then this image that gets taken is either uploaded on the cloud or we have some on-prem analysis. If it's in both ways, if it's cloud uploaded or is it analyzed on the site, there is one machine learning image processing pipeline which has multiple stages, which analyzes the image and creates really precise statistics of the food that is getting wasted, of the pictures that are being taken, and it both reports the class of the image, and also the weight. So it's really valuable information to the customers. All of this data is then getting logged to the customer dashboard, which our customers can access at any time from anywhere, and then they can see the statistics of their food waste. But again, our customers, without any support, they wouldn't know what to do if with some numbers, if they're wasting, I don't know, this amount of bread or this amount of eggs. And that's why we have a whole department of customer support, which really gives like a curated, really takes care of every one of our customer and analyzes the data with them and gives feedback on how they can improve and how they can reduce the food that they're wasting. And then in the end, of course, the most important thing is that they will have some savings, and this is what actually drives all of this, because I mean, reducing food waste is nice, but if there's no cost benefit of that, then why would anybody do that? But there is a lot of cost benefit. Approximately, for like an average of per kilogram of food, it's cost like 10 euros. And each kilogram of food that is wasted is actually equivalent to 5 kilos of CO2, which is really a huge impact on the environment and on the budget of the property of our customer. We saved more than 1 million tons of CO2 right now, so we're very proud of that, just by giving the feedback and working with the customers on reducing their food waste. And also they can save, approximately we save around 2 to 6% in budget, in money, by reducing the food waste. But we have seen really some crazy examples and really good customers that saved over 30% and 50% of their food that was previously being wasted, and of the cost that they were taking. We have kind of interesting examples here, because there were some hotels, and I won't go into much details, but we had a customer that had, I don't know, that didn't know that they wasted 200 kilos of bread each day, and they were just ordering too much of croissants, answering too much of bread or whatever, and they didn't know that, because they're a huge entity, huge corporation. They weren't aware of that, and it's compounds to a lot of money. But in the end, when using our device and using our process, they could quickly notice that the alarm went off, and then they could really take action at time and not waste a lot of money. So that's really cool. I see one question, it says, super interesting, how well do the models handle different types of food versus different types of buckets, particularly to things like sauces or blended foods, do we fine tune them per cuisine? Well, I will try to answer these questions. Really good question, thank you, in the next upcoming slides. All right, now this is the interesting part for the machine learning meetup. In the machine learning pipeline, and how do we do this? Now, I would like to emphasize this presentation on how to define different food classes, how to find new classes that could be labeled. Like in every problem, whatever you're doing, I'm talking to my friends, and yeah, a lot of them that are working in different companies, they all have similar challenges. Like we have some classes, I don't know, somebody is trying to distinguish between Coca-Cola bottles, if it's Coca-Cola Zero, Coca-Cola, whatever. And it's really hard to say, okay, these are the classes, and this we will put together as a single class, I don't know, a Coca-Cola. And this is really a challenge. But here, really FiftyOne really comes to to help us, and but just by using visualizations and a lot of different things that FiftyOne provides, we can really good defined food classes that we'll be using. What is the useful data? This is something of a question here. Like we have different types of food, different types of buckets. Like what is the useful data? What can we do with the data? What do we need to recognize? What do we don't need to recognize? and how to recognize if, I don't know, multiple things are thrown in the bin. What if something already is in the bin? All of these questions we'll try to answer in the upcoming slides. Okay, first let's try to answer these first two questions. So to first define what are the classes, it's always a challenge between machine learning and business. But here in Kitro, we kind of are lucky because as we look at the embeddings and things that can clearly separate, we can see that a lot of classes that are useful for the business side are also the things that we can actually really successfully distinguish from the other classes. But our kind of broad spectrum, our division of the classes is first, maybe somebody throws a knife in, maybe somebody throws some paper in. We have to distinguish if it's edible or inedible, because our customers don't care if somebody's throwing, I don't know, ice, or if somebody's throwing whatever wooden cutlery. And then we have other distinguishing between other, I don't know, if it's plant origin, animal origin, if it's this meal, that meal, or whatever. For that, we actually, we do use a lot of the visual embeddings, and we try to see what model tries to separate. We have these bigger models that can really that can get us really good embeddings, and when we visualize them in the FiftyOne, it really gives us an idea of what the classes would be and what is the best approach to them. All right, how to find new classes? That's what I kind of answered already. We need to visualize the embeddings. We use the similarity feature very much, and we sync with the business a lot of times. So this kind of actually answers this question, particularly like how do we distinguish between sauces, blended foods? It's a thing that gets discussed a lot with the customers, and also with the business side, and also with us, where all these three sides are kind of involved, and we try to see I don't know, what classes are important and how can we put them together. All right, now let's get on to the maybe most interesting part, at least to me. Okay, what is the useful data? How to recognize multiple things? What we have? We have a pipeline that goes into multiple stages. I won't go into very much detail about the models and all the things that we use here, but sometimes an image gets taken with a hand that is already throwing in some food waste, or we have an empty bucket. Maybe somebody emptied the bucket and returned it back. Okay, the scale gets again triggered. We need to detect this, not to classify an empty bucket. Next thing is, all right, I'm sorry for the really explicit images. I will just go through them fast. So yeah, not very appealing, but that's food waste. We have to detect the region. And this really works very good because sometimes the scale shifts, sometimes the box shifts, and it's really crowded in the kitchen area. So you can see here in this image, some of the box, just the whole device and the food waste bin gets shifted, but we still have the really nice picture of the center of the bin. And now to answer one more time the last thing about the first question, like how well the models handle different types of buckets. They handle it really good, actually. I'm quite surprised. But with this procedure, by splitting up this task to some smaller tasks like error detection and this region detection, we can really, the type of buckets that is being input here really doesn't matter to us. We have really big data sets. We get up to 20,000-30,000 images per day, maybe even more. It depends if it's Christmas or is it Sunday. And so we managed to work. We managed to train our models really well. And then in the end, what is important is to see what has been newly added to the model, to the bucket, and just classify it. And then in the end, we have some kind of just a lot of safe checks so I don't know, somebody steps on the scale and then it shows 30 kilograms, 50 kilograms. So we do the regression just to estimate how heavy is the food here. And so we know if it's if what scale gives us, is it a good approximation or not. Yeah, a few remarks on this is that it's really, we really approach this problem like, I don't know, like we're landing a lunar mission on the moon or on the Mars or whatever. We really have a lot of fail safes. We have a lot of different models that get triggered and that make sure that the data is really good, really correct. So we don't have some skewed statistics for the customers. So they really know what is being thrown in and what can they do to solve this problem that they have. The last thing that connects to this thing that I was saying is how to identify mistakes. Of course, no model is 100% correct, and I mean, even if you train models on the MNIST dataset, you will get some, you will have some noise in the data, and you will not have 100% accuracy. You can try. And does the data change during time? And this is something that is really important. So data really does change. There is like a data shift. It depends on the food waste, it depends on the season, it depends on a lot of things that the restaurants are doing. And the data really does change. So a lot of things, so for all of this, for the whole pipeline, we need to retrain our models all the time with the new data, so we have, so they don't drop in accuracy or whatever. Yeah, and how to make sure there are no mistakes and how to label the data set. These things, all right, so first we have, just to make sure that all of the data is correct, we have an internal DV team, data validity team, that labels the data and gives us also the business perspective and gives us feedback for how good our models are and how good the accuracy and is of our models. So we have this constant feedback that is coming to us, and so we can improve our models like every day, every month, every year. Also, we have a really close cooperation with Adapt Technologies. We do data they provide us with data labeling, data validity, and data curation. And for not all of this, but for data curation, we use actually FiftyOne for that, because FiftyOne has all of these really cool plugins that you can just customize, and you can do whatever you want. And it's really cool. FiftyOne is really cool tool to do that. Okay, so first, currently our machine learning model performs better than human agents. We got to that point that when you look at the agents and the data validity and a lot of these things, a lot of different steps in the whole pipeline, when you look at the image, first the human says, okay, this is a carrot, and then machine learning model says, okay, this is something else. And then when you really look at it and then you see, okay, it's really true. Our machine learning models have really high accuracy, and we really have a high automation rate. Around 90% of the data gets automatically labeled, and just because we emphasize so much on the data and the labels being correct, a small portion of the data goes through the checking or manually labeling. Sometimes in all of the data sets, you won't have really completely data sets that have perfect number of samples for each class. So you won't have a balanced data set. Sorry. So of course, when the customer comes or somebody or our business team comes to us and says, okay, we need to add a new class, I don't know, I will say sushi, although it's not sushi, and we don't have many examples of sushi, although we do. Maybe it will be harder for us to label this data. But to be sure that the customer is getting the right labels, we have a team that is all of this data directs to the human agents, and they manually label these data that we are not sure, as the ML team, we're not sure that we can still give the high enough accuracy and precision of labeling. All right, I will try first. I think I passed my 30 minutes. I will try to answer some questions, and then I'll show you a bit more about the 51 route that we are using. So first answer the question. So you only detect raw food and not boxed ones. I volunteered at high school during lunchtime, and students were throwing their milk boxes as is, unopened. Is your system able to detect those? Well, we can. We have different classes that have yeah, we have different classes and different labels for each thing. So if you have these boxes and you know what is inside of them, then we can detect, okay, these are, I don't know, paper, these are cardboard boxes or plastic boxes or whatever. But if they're full and you know they're full, then you can say, okay, this is actually edible waste. And if they're not full, if we can see if they're empty, then we can say, okay, this is not edible. This is just waste. So we do not actually label only food, not only edible, we also label paper, we label coffee grind, we label cutlery, we label a lot of these things that are not actually food waste, but restaurants and hotels and canteens tend to throw them in the bin. All right, do you train the model on a standard generic set of images or on images provided by the customer for their specific case? That's an interesting question. We use a variety of custom models and off-the-shelf models, and we're constantly developing them using the curated data. And we do not, I mean, there are really not that many, and there are not a lot of like open source data sets of food waste. But luckily, we do have a lot of these images, and a lot of these images, we have them labeled. So that's why we can achieve such high accuracy. We have the clean data sets. So we usually train our models on our custom proprietary data sets. If the customer comes with some new data, some new classes, which we don't really have that often, that doesn't happen. We really kind of cover the whole area. But if somebody would come with some special images, we would just we would first measure with them, we would establish the device, we would take some pictures for a month, it would have a lot of trash events, we would label those images, retrain the models, and then we would be able to provide the service for them. What is the size of your data set? Oh, it's hundreds of thousands of images. So we have really a lot of images. And the size of the data set, I mean, it could be even millions of images, but that data set shift doesn't enable us to use the whole data set all the time. We kind of have some kind of a sliding window, and we don't use the whole data set just because we saw that it gives the better performance, really. Do the errors made by human labelers and automatic labeling tend to be correlated? Yes, there are a lot of things that are really hard to label. I don't know, like the first person said, some kind of sauces or something like that. Sometimes these things are really hard to label, so it's really hard both for the machine learning models and for the human. That would be the answer for that. All right, how would you know that is full or empty? I mean, we have the model that uses, like I showed, that shows us if it's, that if it's full, I suppose this question is for the bucket. We see it on the image if it's full or empty. Then again, how customizable is the algorithm based on organization needs? Like I said, it's really hard. I mean, we don't see a lot of problems that we did not solve already. But if you do have some of them, maybe you can just let us know. So maybe it will be a challenge. But most of the images, most of the classes we already have covered. Yes, the food waste is measured at the same time, of course. Okay, I'll try to answer. I will just pick, I'm kind of out of time, so I'll just pick maybe one more question. All right. Oh, this is interesting. Do you plan to using large language models as part of your pipeline? We do have some larger language models that are helping us in the curation and labeling of the data. All right, I will now stop answering questions. I just want to show you a few funny examples. The first one is we sometimes have really bizarre trash events. For instance, you can see this octopus. I believe it's not really octopus. I guess it's a toy. And sometimes we see these burnt pizzas or burnt things that really. So we know somebody messed something up. Okay, one more thing that I want to show you is how we use the FiftyOne. I hope this will work now. Okay, and this is just basic FiftyOne dashboard, and I just labeled some of the images from January, and you can see some of these examples. We have these kind of semi-transparent images that give us like the food weight and what is the label here. And using the grouped feature in the FiftyOne, we can see the previous image and the current image, and then we can see the segmented classified image here. And all of this is really, really useful for us. Also, if you use this and go to the embeddings, we can see that probably there will be a cluster. Okay, we can look at this cluster here. I think this might be something interesting, and then you will stumble into a lot of yellowish bananas and fruit, and there will be a lot of cool things here. Again, you can see the previous image and the current image. And for this, and really the FiftyOne is really, really useful to us.